So the first example, the function f of x equals x cubed plus x plus 1 is increasing for all x, making f 1 to 1. This means f has an inverse. Let g be its inverse. Okay, so really all of that information is just telling us this is our f and it has an inverse. G is the inverse. Increasing, a function has to be 1 to 1 for it to have an inverse. That's why it's saying that, but it's really okay if you don't know what that means. What is an equation of the line tangent to g at the point 3 comma g of 3? And some people are like, what the heck did I just read? Who's writing hieroglyphics for this? And I don't get it. Well, first, it's asking, what are the key pieces? What is an equation of the line tangent to g? So I need the slope. What do I need? I need slope of g. I need the slope of g when x equals 3. When x is 3, I need to know what the slope is. And I also need what? An equation. I need y minus y1 equals m times x minus x1. I don't expect you to have remembered that, but now I think I'm going to expect you to remember it. This is called, I think, point-slope form for a line, and we're going to use this. So the first order of business is to find the slope of g. Well, I have a formula, which is f inverse. If I want to take the derivative of an inverse function, that's going to be 1 over the derivative of the regular function composed with the inverse function. But here's the thing. That would be what? F inverse. Here's the thing. I don't have the inverse function. What? That's crazy. That's crazy. I don't have it. But I do know some things. I do know that since this part is on g, that means g of 3, comma 3, that is a point on f, right? So let's think about this. If I'm plugging in, well, let me maybe rewrite. I'm going to rewrite my formula, because I'll have the derivative of g, which is an inverse. So that's, instead of writing f inverse, I'm going to write g. So I'll say the derivative of g, g prime, maybe I should plug in, sorry, that's supposed to be x. G prime of x, that'll be 1 over f prime of g of x, right? Well, look at this. That, I already know. I think the problem is, we might have to back up a little bit. I think the problem is I don't know what g of 3 is. I don't know what it is. Because if I did know what g of 3 is, I could just plug it into the formula. Because I can easily find the inverse of f. Because I'm looking for the derivative of g. That will give me the slope, because I need the slope of g when x equals 3. So how am I going to go about finding out what g of 3 is? Well, I know that the y value on f, this is just from my inverse rules, I know that the y value on f has to be 3. So that means maybe I can do this. F of x equals x cubed. I pause the music because I need to think. Plus x plus 1. That has to equal 3 at some point. So I can say 3 and then x cubed plus x plus 1. I guess subtract 2. So 0 equals x cubed plus x plus or minus 2 if I subtract the 3 over. So that's minus 2. I can't really factor. I guess we could use synthetic division on this. Maybe if you get a problem like this and you're unsure how to solve it, you just ask me. I'm not going to give you something like this on a test, but the way Khan Academy does it is they graph the original function and then they just look at it. So I guess you could graph it on a graphing calculator if you have a graphing calculator. But here, if I just start guessing, which is really what synthetic division is, if I just start guessing, I figure out that 1 works. That's just by guessing. Because if I do 1 cubed plus 1, that's 2, and then 2 minus 2 is 0. So that's just from guessing. So from guessing and checking, I know that if I have a y value of 3, this is for f of x. If I have a y value of 3, then the input is 1. That means for g of x, it's important to write this down. For g of x, that means 3, 1 is on my function, which means g of 3 equals 1. Now I can find out the slope when x equals 3. So here we go. G prime of 3, that will be 1 over f prime. What is f prime? That would be f prime of x. That'll be 3x squared plus 1. So that would be 3, and then I put g of x in there. Well, I'm plugging in 3, so I put g of 3. So 3g of 3 squared plus 1, because I'm just composing the two functions. And what is g of 3? g of 3 is 1. So I have g prime of 3 equals 1 over 3, 1 squared plus 1. That's 3, 4. So that's 1/4. So g prime of 3 is 1/4. That's the slope that I needed. So I'm pretty close. Now I can use that equation. This is the first example. These must be crazy. Yeah, we're gonna do a lot more examples. Maybe whiteboards, probably whiteboards. All right. So what do I have? Y minus y1. Y minus, well, my y value. I need a point that's on that's G line. And I'm gonna use that because I already know y minus y1. So y minus 1 equals slope 1/4 times x minus 3. Those values are on the line that's tangent. It's on G, but it's also on the line that's tangent. If I were to draw it out, like if that's G, and I'm looking for the equation for this line, well, I already know that this point is on G, but it's also on that line, so I'm allowed to use that in this equation right here. I know that was confusing. We'll definitely do a lot more, but this is, I guess, one example for this video. Goodbye. Good see you. Sayonara.